Fastest way to determine if an integer's square root is an integer. Introduction. A common coding and interview question in Java is, how do you quickly check if a number is a perfect square? In other words, does the square root of an integer come out as another integer? Example: 16 means 4, perfect square. 18 means 4.24, not a perfect square. This topic explains what a perfect square is, fast ways to check it in Java, why floating point methods can be risky, efficient integer-based solutions, bitwise optimization ideas, edge cases, and best practices. This is a classic algorithm plus performance question. Problem statement. Given an integer n, determine. Is root of n an integer? Return. True means perfect square. False means not a perfect square. Naive approach, double root equals math.sqrt n. If root equals int root, return true. Floating point issues, precision errors. Example: math.sqrt 21473956000 may produce 46340.99999 instead of 46341. X. Unreliable for large numbers. Best general approach. Fast plus safe. Use integer square root and check int root equals int math.sqrt n. Return root times root equals n. Why this works. We compute integer root, square it back, compare with original number. Example: n equals 25. Root equals 5. 5 times 5 equals 25 means true, n equals 26. Root equals 5. 5 times 5 equals 25. 26 means false time complexity. Check O1. Because single SQRT operation, constant time multiplication, very fast for most applications, even faster integer method, no floating point issues, binary search approach, public static boolean is perfect square, int n. If n equals 0, return false. Long left equals 0, right equals n, while left equals right. Long mid equals left plus right 2. Long SQ equals mid times mid. If SQ equals n, return true. If SQ equals n, left equals mid plus 1. Else, right equals mid minus 1. Return false. Why binary search works. We exploit. Check. Monotonic function. X squared increases steadily. Complexity method. Time complexity. SQRT plus check. O1. Binary search. O log n. Fastest practical method in most Java applications. This is best. Int r equals int math square root n. Return r square root equals n. Capital simple, fast, widely used, safe enough for most cases. Edge cases. 1. Negative numbers n less than 0 means always false. 2. 0, 0 is a perfect square. 3. Large integers. Be careful with overflow. Mid. Use long instead of int. Alternative, Newton's method, advanced. Faster convergence method. X equals x plus n over x times 2. Rarely used in interviews, but very fast. Comparison of methods. Method, speed, accuracy, complexity. Math.sqrt plus check. 6 skill, medium, ov1. Binary search. 6 skill, high, o log n. Newton's method. 6 skill, high, o log n. Common mistakes. 1. Direct double comparison root equals int root. Unsafe for large numbers. 2. Using float instead of double. Precision issues increase. 3. Ignoring overflow, mid times mid. May overflow int means use long. Best practice. Check. Use math.sqrt plus integer check for simplicity. Check. Use binary search for strict accuracy. Check. Use long to prevent overflow. Check. Handle negative numbers early. Real-world use cases. Cryptography, geometry calculations, game development, algorithm challenges, data validation. Simple definition, perfect square. A number whose square root is an integer. Example, 9 means 3, 16 means 4. Final summary. The fastest and most practical way to check if a number's square root is an integer in Java is int root equals int Math.sqrt n. For more precision, use binary search method. Key idea: compute square root once, then verify by squaring back. This avoids floating point errors and gives a fast, reliable solution.